Well, hello and welcome. If you remember, last week we were talking about R values, exponential growth, and I had you figure out total numbers of cases because our function we were doing gave us how the growth was with new cases. So we said n was an interval of time and that f of n was the total new cases, and I was having you figure out totals, right? So one of the things that we were talking about is we saw a graph. We saw how these things grow exponentially, and I had you figure out total number of cases over time. Well, in calculus, when you do continuous data, that area under that curve is called an integral, and that is very related to what I was having you guys figure out. So let's just review where we were, right? F of n is the total number of new cases over a certain time interval of n, right? And so if we fill out the chart and we just add to find the total, we can find the total value just by, doing the addition. But then we tried using this formula, and the formula worked because we saw that each time it was one less than whatever the next one was. And so we went ahead and we did that last week. We found that 2 to the power of n minus 1 gave us the total number of cases for r equals 2. So then when we were going over it together, I made a mistake and I should have known better. Definitely should have known better, but I tried to use the same exact formula for r being 2.7. And it didn't work. It didn't work at all. Epic fail. So what I wanted to do today is kind of show you how, without using calculus, I was able to figure out a formula, and I want to share that formula with you. So I just started exploring. I started saying, well, what happens when r equals 3? I filled out the same chart, did the new cases, did the total by addition, and what I noticed was that, I'll slide the paper up right here, what I noticed is that each time when I did my formula, 3 to the power of n minus 1, I was twice of the total. So if I divided by 2, it would work. So 3 to the power of n minus 1 divided by 2 worked just fine. So I plug in 4 and I get 40. So I noticed that if I'm dividing by 2, well, that's 1 less than r. So I tried using this formula, r to the power of n minus 1 divided by r minus 1. So I went ahead and tried that with our value of 4. Went ahead and filled out the chart for new values, did the addition, and then I tried the formula, right? So I tried first with n equals 5, plug it in, it should equal 341, and it does. So I'm like, all right, hey, that works perfect. So I'm going to try that same formula for 2.7. So let's go ahead and plug in a 5 and see if it works. So 2.7 to the power of 5 minus 1 divided by 2.7 minus 1, which is 1.7, right? So just using our handy-dandy calculator right here and doing the subtraction and then doing the division, and boom, it works. Do you see? So, oh man, bruised thumb, that's bad. Thumbs up for the formula, thumbs down for a bruised thumb. I don't even know how it happened. So just to check, to make sure, I can plug in all the different values, and we can see that it works. It works just perfect every single time. So the takeaway is that by just exploring, a lot of the times you can find things out. But when you guys move on and you do take calculus and you learn how to do an integral, you're going to see that you're going to come up with formulas kind of like what we just found right here. So anyway, I hope this provided some clarity. If not, send me an email. Have a great day.